There it is. All right, so let's try to finish this up. Hopefully we'll be able to finish this today. So I'm gonna write down what we started yesterday, or not yesterday, whatever it was, last time we had class, Friday, and just kind of start from the beginning of this. So here it is. I'll just write that fraction out. We started it. We got a little bit into it, but we didn't quite get there yet. So I think the problem says, I don't think, in my notes I didn't write exactly what the problem says. It says something about decompose the fraction into partial fractions, I think is what it says. Anybody have the book in front of them? Look at the, this isn't one of the examples. Oh yeah, I got it, the other example. Yeah, decompose this into partial fractions is what it asks you to do. All right, what in the world does that mean? I'll write that down. At least I'll write down decompose. Decompose. Okay, into partial fractions. Well, what's a partial fraction? A partial fraction would be, I don't know, like 3 over x plus 2 over x minus 1 or something like that, okay? This is partial fractions. Everybody got that? All right. So if I did this, what would I do? I have to find a common denominator, right? Then find the numerators, and I'd get some one big old fraction. Well, this is my one big old fraction. So what do I want to do? I want to break it down into two fractions that either add or subtract to become this. All right, so it's kind of like I'm starting with the answer and I'm coming up with the question. I'm starting off with the sum, and I want to come up with the things that are being added. What do they call those, like addends or something like that? I never really used those words before, but that's what we're trying to do. So let's do this. First thing I'm going to do is I want the bottom, the denominator, to kind of look like that. So what am I going to do with this in order to get two things that are multiplied together to become this? What am I going to do with that? What am I going to do to this bottom, the denominator, to get two things that are being multiplied? Give me one word. Factor. Thank you. Okay, we've been saying that word 1,000 times in this lesson, or in these last few lessons, okay? So we're going to factor that. So let's do that. This is just a regular trinomial factoring, nothing special about it, nothing tricky about it. So I've got an x here and an x here. That multiplies to this. You've got to find two numbers that multiply to be 20, positive 20, and add up to be 9. Okay, it's pretty easy. Which numbers are you going to use? 4 and 5. Good. Okay, so 4 and 5. All right, so we factored it. And then we have this. So this is a little bit nicer. Okay, so if you have something that looks like this, always try to factor it so you got two things that are being multiplied together. All right, those are factors. When we say a factor, what is a factor? It means this times this. The two things that are being multiplied together are your what? Factors. Got it? Now, here's where I think this was the last thing that we did on Friday. And what we want to do is this. We're going to split into a fraction, or two fractions. We're going to split this denominator. All right, since they're being multiplied together, what we're going to do is we're going to put one of them here and one of them here. Because remember, we're kind of going backwards. All right, if I did the other way, what if I had something on top here, something on top here, and I wanted to add those fractions together? What would I do? I'd find a common denominator, wouldn't I? And what would the common denominator be? It would just be these two things multiplied together, correct? All right, so again, we're kind of going backwards of an addition problem, all right? So what's going to go up here, though? Is it just going to be a 3x, and is it going to be a 10? No, because if you added those together, that's not what that would be. So I'm not sure what that's going to be. Anybody look at their notes? What did we make this? Because I'm not sure. I don't want to make it an x because I already got x's down here. So what did I use? I mean, a and b, right. So I'm like, okay, I'm not sure what this numerator is going to be, so I'll call it a. Everybody got that? I'm not sure what this denominator, or this numerator right here is going to be, so what do you think I can call it? B. I mean, you can use any letters you want. I would not use x for sure because you're using x down here. You can use any letters. They use a and b. I'll use a and b. We good? So now what I got to do is where we kind of ended up. I think that's where we stopped on Friday. Is it? I don't know. Did we do another step?
We didn't do any of this on Friday.
You sure?
We
didn't get to this?
We just wrote the 3x plus 10. And
I think we did this, didn't we? I mean, I could look. Yeah, that's what I'm saying. That's what I'm saying. That's where we stopped. So yes, Mr. Hamrick, you're right. All right. So this is new. From now on, it's new. All right. So what we're going to do is we are, I know where, sorry. I'm going to move this over a little bit, and I'm going to set it equal to what it was equal to with the split up fractions. Yes. So I'm going to go, so really I could have taken all this stuff right here, but I'm just putting it down here so I have a little bit more room to write. That's all I'm doing. So it's 3x plus 10 over x plus 4 times x plus 5. So that's really not a step. All I did was just bring that stuff down here. Okay, that's all I did. Everybody got that? So here's what I want to do. I want to find what a is equal to, all right? And then I want to find what b is equal to. If I can do that, I can put the a right there, I can put the b right there, and then I've split this thing into, what did I call it? Partial what? Fractions. And that's what I'm trying to do. I'm trying to go from that one big old fraction right here, that 3x plus 10 over x squared plus 9x plus 20. I'm trying to go from that, and I want to make it look like this. You understand what we're trying to do? All right. And I just don't know the a and b. So I got to find the a and b. So there's a couple little tricks that you have to do. First thing I want to do, I don't like all this fraction stuff. Okay, I want to get rid of my fractions. So how, and I did a little stuff on Friday to prepare you for this, of getting rid of the fractions. So what do I do to this whole thing right here, this whole equation, in order to get rid of the x plus 4 and the x plus 5 on the bottom? Multiply everything by, well, the common denominator, which would be what? Just x plus 4 times x plus 5. That's right. So I'm going to multiply everything by that. All right. So I'm going to multiply this by x plus 4, x plus 5. I'm going to do it to this, x plus 4, x plus 5. So I did this to both things on the right-hand side, so guess what I got to do? I got to do the same thing over on the left-hand side. All right, so let's put it over here. Why did I put a 3? Don't know why. X plus 4, x plus 5. Now this makes things easier. Right now it's not. It looks kind of ugly now. But guess what we're going to do? If I multiplied everything by the common denominator, then that common denominator is going to cancel out. So I won't have any denominators. That means I don't have any fractions. And we're all happy, right? When we don't have fractions? Yes? Okay, give me a little nod that you're still living. Here we go. This x plus 4 and x plus 5 cancels out with this x plus 4 times x plus 5. And we're just left with a 3x plus 10. We'll write that down in a second. What cancels here, though? The x plus 4 cancels with this x plus 4, but we still have a what? An x plus 5 times that a. We'll do that in the next step as well. What about this? This x plus 5 cancels out with this x plus 5, but I'm still left with this x plus 4 times this b. Everybody with me? Let's get rid of that circle. All right, so let's rewrite everything. And now we're not going to have any fractions, which is good news, because none of us, myself included, would rather do stuff without fractions, wouldn't you? Absolutely. Life's not like that, but it's nice when it is, when we don't have fractions. All right, what about that? That cancels, so what am I left with? A times x plus 5. I'll show every step so that when you look back on this, hopefully you'll understand what we did. This x plus 5 cancels, so I'm left with this x plus 4. It's being multiplied by the b, so I'll multiply that by the b. All right, I'm gonna leave it like this, actually, right now, because I got to solve for a and b. I don't know if you ever remembered in your algebra class. I don't know if I mentioned this in geometry or not. I probably did, because I just mentioned this to my CP geometry class when we were doing stuff. Remember, we had to solve for substitution, elimination. We did a lot of that in here, didn't we, at the beginning? If you have two variables, you must have how many equations? 2 equations, okay? Or you could substitute something in, right? So what I'm going to do is this. It's kind of a trick, a little bit of a trick, all right? Let's say I want to solve for a because I want to figure out what's going to go right there. So that means I want to get rid of that b. Don't want the b there. All right, I just want the a. I'll keep the x's, and you'll see what I'm going to do with those x's in a second. All right, so what I'm going to do is make this x something that the b will go away. Did you hear what I just said? I want to put in something in for this x in order to make that b go away. Say it. -4, exactly right. So what I'm going to do is this. Again, it's kind of a little trick. So I'm going to let x equal -4. All right? I'm just going to say, all right, let's let x equal -4 so the b goes away. To tell you the truth, I really don't know like a rule that allows you to do this, but that's what we do. All right? It's a trick. All right? So I'm going to let x equals -4. So what happens here? Do I have to really put it in for this one? No, because that's going to be a 0. 0 times b, that just goes away. Agreed? All right. But if x is -4, I got some x's here, so what am I going to have to do with that? Put them in. Right. Take that -4 and put it in for those x's. So let's do that. So it's going to be 3 times -4 plus 10. I mean, you might have been able to do that in your head, but we're going to show every step just so, again, when you look back on your notes, you'll know what's going on. Equals a times x. What did we say x was equal to? -4 plus 5. I put it in here and it went to 0. 0 times b is 0, so I don't have to worry about that. Now check this out. I got all numbers except that a. And now I can solve for a. So let's do that. What's this? -12. I don't have to do every step here, do I? -12 plus 10 is -2. What's this? -4 plus 5 is 1. 1 times a is a. So look at that. I'll just write it nice. A equals -2. So check it out. That's what we wanted to find, isn't it? We wanted to find what a is equal to. We'll put it in there in a minute. Let's just keep it there for safekeeping, okay? Let's do the same exact thing that we just did, but this time, instead of getting rid of the b, what do you think we're going to get rid of? Get rid of the a. So let's do the exact same thing, all right? Should I scooch it? Yeah, let's scooch it. All right, so let's write that same thing, 3x plus 10. So all I'm doing is rewriting this. All right, equals a times, and again, you might be able to do some of this in your head, but I'm trying to show just about every single step I can. All right, so I let x equal -4 just so that that b would go away and I could figure out what a is. But this time, I want to get rid of what? I already got a, so what do I need to find now? I need to find b. All right, so what should I be able to do now? Let what? Let x equal -5. Good. All right, because I want to get rid of the a. So if I make this x -5, -5 plus 5 is 0 times a is 0. The a cancels out. All right, so I know that's going to cancel out. I don't actually have to put it in there. I can do that much in my head. Let's do the rest. This is going to be 3 times -5 plus 10 equals b times -5 plus 4. All right, now I can solve for b. I got all numbers and I got b, so it should be pretty easy. Let's do this part in our head. -15 plus 10 is -5. -5 plus 4, that works out nice again, just like the other one. That's a -1 though, right? It's not just a positive one like this was. So what's this over here? That's -b. So what's b equal to? +5. All right, we'll put that in a little box. And that's basically our answer. We just got to put it all together and make it look real nice. So let's do it in a different color so I don't get it all mixed up with everything else. So that must mean, what do we start with? 3x plus 10 over, what was it, x squared plus 9x plus 20. So I started with this. What did I end up with? A over x plus 4. Well, what's the a? It's -2. So you put a -2 right there. What is the b? What did we get for b? We got +5, didn't we? All right, so I can put a plus there since it's positive. And what was my denominator? Well, that's an ugly, was that supposed to be 4, right? It's an ugly 4. There we go, a little better. What was our denominator over here? X plus 5. And what was that again? 5? And there you go. So You don't really have to rewrite that beginning stuff, but I wanted to put it there just to show you what we did. What did we end up doing? We took something like this, right, and we turned it into partial fractions, which means a fraction plus another fraction. Or it could be minus, all right, just depending. If that came out to a -5, right, you could have put minus. Or you could have written it the other way. You could have written that 5 over x plus 5 minus 2 over x plus 4. That would have been okay. Doesn't matter, right? Commutative property doesn't matter what order you add things in. All right, so basically that's your answer right there. That's not so bad, is it? All right. From what I understand by watching all these YouTube videos is this process is very helpful in calculus. All right. So I'm not sure exactly where. It's been years and years and years and years since I've done calculus. So I'm not really sure, but that's what I'm told, that this will kind of show up as part of another problem. It's not just this problem. This is just one skill set that we use to do other stuff. All right. And that's what a lot of high school math is, really, right? You learn how to do certain things in order to be able to do something else, right? Then you learn how to do that, and you learn that so you can do something else, right? And that's what we're doing here. We're learning this so that we can do this in a calculus problem. That was just a pre-example. That's just an example I found somewhere else. It's not in the book, but it's a good problem to do. Let's do the one actually in the book. And this is example 3. And we'll go a little quicker now since you kind of got the basic idea. So this is example 3. And it might even be a little bit easier. And they use y instead of x. They could use any letter. It doesn't matter. And they say, what does the question say? Decompose this into partial fractions. All right, if you want to jot that down somewhere, okay, I'll just say partial fractions. So I'm not really solving for anything, am I? I'm not solving for x, I'm not solving for y. All I'm doing is just changing what this looks like. By the way, I don't have enough time to do this, but if I had enough time, if you wanted to, you could take this fraction right here and do what to it? You could add them up, couldn't you? Find a common denominator, right? Multiply everything by that common denominator, work it all out, and what should you end up with? You should end up with this thing right here. All right, give it a shot, see if it works. If we had more time, I would do it, but I want to move on. All right? So if you want to try that, that's because these are exactly the same. And you've done this stuff before. You've added fractions together with different denominators to get this. But what you really haven't done before is taken that answer and coming up with what our problem was to begin with. All right? All right, enough of that. Let's do this. What do you think our first... So I want to take this and I want to turn it into partial fractions. What's the first thing you think I'm going to do here? Factor the bottom, right. Factor that thing right there. So let's do that. So I'm going to go 8y plus 7 on the top over, and this is an easy factoring. It's not a difficult factoring, all right? And it's y and y. What is it? Plus 2 minus 1? Yeah. All right, super easy. So that wasn't a big deal. That should be easy for everybody. Now what do? Now we have to make it look like this plus this. What are my denominators going to be? Y plus 2 and y minus 1. What's my numerator right now? I don't know what my numerator is going to be. I got to do some work to get there. So what am I going to make it right now? Just make it a and b. All right, so those are just temporary until I can figure out what's supposed to go there. We good? All right. Now look, I got an equation, right? I got this stuff equals this stuff. All right, so I don't like those denominators. So what am I going to do with those denominators? Multiply it by a common denominator, which would be y plus 2, y minus 1. Do the same thing here. All right, y plus 2, y minus 1. Same thing here. Y plus 2, y minus 1. I mean, the math on any of this hasn't been hard, right? You just got to know what to do, what step to do when, and that kind of thing. This made it nice. What happens over here? That does what? Cancels out with that thing right there. We'll write all the stuff down in a second. What about this? I got a y plus 2 here on the bottom, don't I? And it cancels with that y plus 2 on the top of that. Same thing here, that y minus 1 cancels out with that y minus 1. So let's write it down. It's just 8y plus 7 equals, what do I got here? Can we do this in our head? A times y minus 1? Let's do that. Actually, I don't want to do that. I lied. I want to keep it a times y minus 1 because of the next step. All right, and this is b times y plus 2. All right, so now it looks a lot better. All right, it's nice and streamlined looking now. No fractions. Problem is, how do I solve for a? How do I solve for b? There's another way to do this, but the way that we're doing it right now, letting y equal a certain number, I think is the best way for right now. There might be some problems where it might be better to do it another way, but I'm not going to do that today. We'll just do it like this. So what do we say? Let's just solve for a first. Is that all right? So let's get rid of the b. If I get rid of the b, what do I let y equal? Negative 2. Very good. All right, so if I let y equal negative 2, that's negative 2 plus 2 is 0 times b is b, so that'll go away. But I got to put that negative 2 in for the other y's as well. Okay? So 8 times negative 2 plus 7 equals a times negative 2 minus 1. All right, that's negative 16 plus 7, and that's, what's that, negative 3, negative 3a. Am I doing the math right? Okay. What's that, negative 9 equals negative 3a. Divide both sides by negative 3. A is positive 3. I'll put it in a box. It's not my answer, but I'll put it there for safekeeping. Now what do I do? Solve for a. All right, so let's write that down. We could write it right. Let's write it right here. So it's 8y plus 7 equals, well, let's just write it all out, I guess. I was going to get rid of it right off the, I was going to get rid of this. Did I say solve for a? I meant solve for b, sorry. A times y minus 1 plus b times, and you might be able to streamline this a little bit. All right, and so what are we going to let? Over here we let y equal negative 2 because I was trying to get rid of the b. Now I'm trying to get rid of the a and solve for b. So what am I going to make this y in order to make that a 0? Let y equal 1. All right, so you know that'll go away. What's this? 8 times 1 is 8 plus 7 is 15. Put a 1 in for this. 1 plus 2 is 3 times b is 3b. So what's b equal to here? It's 5. There you go. And you're basically done, but you got to write it the correct way. All right, so let's go up here and see what it was. It was a over, let's do this in a different color just so it pops a little more. There we go. All right, so the first one was over y plus 2. The second one was over y minus 1. So what was the a? The a goes on top of the y plus 2. That was a 3. And what was our b? It was 5. Goes over top of this right there, and that is your answer. Again, if you wanted to, you could add those fractions together, find a common denominator, multiply both of those fractions by the common denominator, distribute the numbers out, add like terms, blah, 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 put it all over the common denominator, and guess what you would be left with? You would be left with this thing right there, okay? So if you wanted to check it, feel free to do it. It takes a minute or two, but it shouldn't be that hard. Make sense? All right, that's the last one of those we're going to do. All right, now we're going to do something just a little bit different. We're not really doing the partial fractions this time. We're going to do an inequality. Everybody loves inequalities. Not really. I'm being sarcastic. But here's what we're going to do. Example 4. Okay, got to get finished before class is over. I don't want to spend any more time on this. So here's what we're going to do. We're going to solve. And I'll kind of show you what we're going to do within the example. Now we still have a fraction. We still have these binomials. All right, look at that crazy thing. All right, everybody got that down? Kind of left out some steps here. I think I did some of this in my head, so I'm trying to figure out. Yeah, let's do this. So, what I'm going to do, we did these a little while back with these inequalities. I think it was in here. I know we did in Algebra 2. Sometimes I get confused between what we did in Algebra 2 and what we did in here because a lot of the stuff kind of overlaps a little bit. All right? Actually, you know what? I don't need it this big. Let's do this. Let's put this here. I need some room to write. This should be good. Let's put a number line right here. What I want to do is find some critical points. I want to put some points on our number line, and then we're going to do something with those points. So let's take the bottom first, okay? You've got x's on the bottom, okay? You've got numbers on the bottom. Remember, you cannot divide by what? 0, okay? You can't divide by 0. So what can x not equal? Not 0. 0 minus 3 is negative 3. I can have a negative 3 on the bottom. It can't equal 3. That's right. Everybody see that? Okay, it's not 0. 0 could be, 0's fine with any of these. All right? But it can't be a 3. Because if x is equal to 3, then 3 minus 3 is what? 0. Right? So x can be 0. 0's fine, but it can't be a 3. So x cannot be 3. So 3 is one of my, and that's probably why I should have written this down. I should have said x cannot be equal to 3. All right, and then come over here and we'll put a 3 right there, okay? We're going to do something with that in a second. What else can x not equal? Look at the bottom. Just look at the denominators. It can't be 4, all right? So x cannot be 4. Because if it was, 4 minus 4 is 0. 0 squared is 0. Can the bottom be 0? No, it can't. All right, so 4 is another critical point. Maybe write that word down. Critical point. Everybody still here? You awake? All right. Snap out of it. If you're starting to nod off, snap out of it, and then start writing this stuff down. Now, here's another thing. We figured out what x cannot be equal to. What I want to do now is take the numerators and figure out what's going to make this thing equal to 0. All right? So 0 over anything is 0, correct? So let's find out what x can equal to become 0. So look at the top. What do I do here to make that a 0? X could equal what? 2. All right? What else could x equal? A 1. So these are all critical points right here. So look for the denominator of what cannot work, right? Or what makes it 0. So really, we're finding the zeros of all of these, aren't we? That's what we're doing. Okay, what makes that 0? What makes that 0? What makes this 0? What makes this 0? All right? So a 2 and a 1 would make that. So guess what we're going to do here? Put a 2 here and put a 1 right there. Now, those are my critical points. Okay, they're very, very important. What they do in the book, they put these dashed lines, I think. I think it's this book that does that. They put some dashed lines like this, which is good. Let's do that. What this does, it breaks it up into 1, 2, 3, 4, 5 different regions. Did we do this before with inequalities? Can't remember if it was in here or Algebra 2. I think it was Algebra 2. All right, but that's okay. I'm showing you from scratch anyway, okay? I'm not like expecting you to know how to do this. I'm just showing you right now how to do it, all right? So what I did, I found those critical points, and now what I'm going to do is I want to pick a point, an easy point, okay? Anywhere inside of here. And then I want to pick a point in between here, between 1 and 2. Then I want to pick a point in between 2 and 3, between 3 and 4, and then anything that's bigger than 4. So I got 1, 2, 3, 4, 5 different places that I want to see what makes this thing. And what are we trying to do? We're trying to find all the x values that make this what? Less than 0. Which is what? What kind of a number is any number that's less than 0? It's a negative number, isn't it? Any number that's less than 0 is a negative number. Agreed? That's what we're trying to do. We're trying to find, do the numbers in here make this thing 0? Do these, do these, do these, do these? Okay, so we're going to try one. So this is a 1. This stuff right here is anything less than 1. So give me a number. Give me an easy number, a very easy number that's less than 1. So I'll tell you what, let's write it over here. So give me a number, x, that is less than 1. 0. 0 is a super easy number to pick, correct? So let's put a 0 in for this inequality, this thing right here, and let's see if it is negative or not. So that means any number to the left of 1. I picked 0 because it's easy, but I could have picked a -1, a -10, a -1,000,000. But would I want to pick numbers like that? No, pick something super easy. So that's what I'm doing. I'm taking any number to the left of 1, and I'm going to put it in for x and see what happens. Does it make it negative? Does it make it 0? It could make it 0. Or does it make it positive? That's what I'm trying to figure out. Everybody hear me? A lot of stuff going on. Heads down, chatting. Most of you are quiet, but I don't know if I got 100% of your attention. So look, snap out of it. We only got like 11, 12 minutes left. All right, so let's look. Let's pick a number less than 0. We picked 0, correct? So let's pick x equals 0. So let's put a 0 in for this. I don't even care what the actual number comes out to be. All I care is, does it come out to be negative or does it come out to be positive? All right, so let's do that. What if I put a 0 in for this? What's that going to give me? I don't care about the number, just negative or positive. If I put a 0 in for that x right there, what do I get? I get a negative. All right, what if I put a 0 in for this? 0 minus 1 is negative, correct? Over. What if I put a 0 in for that? Negative. If I put a 0 in for this, is it negative? Why? Because it's squared. That's right. If I put a 0 in for here, in just the parentheses, that would give me a negative, right? But if I square it, that'll give me a what? A positive. How many negatives do I have? I got 3 of them. 3 negatives makes it what? Whether I'm dividing or multiplying, it makes 3 negatives. Negative, negative, negative. Look, this negative over negative is what? Positive. This negative over positive is negative. So, any number that's less than 0. I picked x equals 0 just because it's super easy. All right? I said less than 0. Any number less than 1. All right? And 0 is in here, isn't it? Would you agree? I could have picked what? A -1. I could have picked a -2. I could have come over here and picked a -37. That would have been stupid, but I could have. All right? Any number is going to make this thing negative. So guess what I'm going to do? That's one of my values. Any number that's less than, I should do this, not equal to, but less than, that was supposed to be red. Let's try this again. Hold on. All right, so any number to the left of 1 is a valid answer for this. Would you agree? Any number less than 1 is going to give me a negative number. That's what that means right there, less than 0. So that works. So every number here will give me a negative in that area right there. What do you think between 1 and 2? So x is between, oops, let's go white. Did I erase something? Watch. What about the numbers between 1 and 2? Give me an easy number between 1 and 2. Yeah, 1.5. Let's try 1.5. Okay, so x equals 1.5. That's not that bad because all I'm doing is trying to see if I get a negative or a positive. I don't care what the actual number is, okay? I just want to see if I get a negative or a positive. So if I go 1.5 minus 2, what's that going to give me? It's going to give me negative. What if I go 1.5 minus 1? What's that going to give me? Positive. You see what I'm doing? Put a 1.5 here. 1.5 minus 3 gives me negative. 1.5 minus 4 gives me negative, but if you square it, it becomes positive. So look what I got. I got a positive. So that's going to give me positive. Do I want positive answers? No. So am I going to shade anything in between 1 and 2? No. All right, let's keep going. What about between 2 and 3? Give me a number between 2 and 3. 2.5. It's another easy number. Let's do a little quicker. 2.5 minus 2 is positive. 2.5 minus 1 is positive. 2.5 minus 3 is negative. 2.5 minus 4 is negative, but when you square it, you get positive. So what do I get when I do all that stuff to it? I get a negative. So guess what I'm going to do between 2 and 3? What am I going to do? I'm going to shade it. That's right. Okay, because any number between 2 and 3 is going to make this thing a negative number. So this was all positive. This was negative. This is negative. Guess what's going to happen here? Well, you got to be careful. I don't want to do that. I want to do every little region here. All right, so this is going to be negative. So guess what I'm going to do? I'm going to do what to it? Shade it in. So what does this tell me? What does that shading tell me? That tells me that any point between 2 and 3 is going to make this thing negative, right? Because that's what they asked for. That's what the question says. What numbers are going to make this thing less than 0 or negative? All right, now let's just do it down here. Let's try a number between what? What's my other region? I just hit 2 and 3. Now it's what? 3 and 4. Again, let me change it back to white. Between 3 and 4. So 3 and 4, x less than. What would that be? Again, let's just go halfway. It doesn't matter. You can use 3.1. You can use 3.9. It doesn't matter. All right. So use 3.5. So let's do it. Let's come back to this original one. 3.5 minus 2 will give me positive. 3.5 minus 1 will give me positive. 3.5 minus 3 gives me positive. 3.5 minus 4 gives me negative, but when you square it, you get positive. So what do you get between 3 and 4? Positive. Do I shade it? No, because I only shade the stuff that's less than 0 or negative. We got one more region. So this is going to give me all, let's keep it color coordinated here. That'll give me all positive. Now, let's try all the numbers that are to the right of 4. It looks like it's going to go in order, right? Negative, positive, negative, positive. It looks like that should be negative. Would you agree? But let's try a point. What's a super easy number to the right of 4? Let's try 5. Okay, let's try a 5. So again, we're going to put it in here. So we're going to try any number. I'll keep it red. Who cares? Any number greater than 4. So let's try 5. You with me? So 5 minus 2 is positive. 5 minus 1 is positive. Over. 5 minus 3, positive. 5 minus 4, positive. Squared is positive. Check it out. It's positive. So this doesn't go to negative, does it? This stays at positive. So what's my answer? Good question. The graph is very, very helpful for us. So our final answer, let's do it in a different color so it stands out. What's our final answer? X can be any number that's, first of all, what? Less than 1, all right? Or where? Between 2 and 3. How do I write that? I put the X here, put less than, put a 2 here, and a 3 there. And that's all my values for X. I can pick any number that's less than 1, or I could pick a number that's between 2 and 3, and that is going to give me all the possible solutions for this inequality. So that was something a little different, wasn't it? All right. If I went a little too fast, go back, watch the video. Okay, slow it down, write it down, try to think about what I just said. But I think I explained that pretty well. I got 3 minutes left. I don't think I'll be able to finish the next one, but I should be able to at least get you started on it. And then you can kind of try it yourself. Here we go. This is example 5. Example 5. And it says to solve. And here it goes. It's 2 over 3a plus, I'm going to get you started on it. And they explain it fairly well in the book. So you can look in the book to see the final explanation. They put greater than 3/4, but all I did was just move this to the left-hand side and put it greater than 0. So now what are we trying to find? We're trying to find all the values of a that make this thing what? Not negative like the last problem, but what? Positive. We want to find out what's positive. So, well, we'll go to the graph in a minute. We got to do something first before we end up graphing. Okay? Here's what we're going to do. We're going to multiply everything by what? 6a. So everything cancels. You can do the work. All right? Multiply that by 6a, 6a, 6a. Do that yourself. You come up with this. Once you get a is less than 2. All right? So you think, oh, okay, well, 2, a is everything less than 2. But we got a problem. What can a not be here? No? It's on the bottom. It can't be what? 0. This one cannot be 0. This time it's not being added, is it? Because 3 times 0 would be what? 0. So 0 is my other critical point. So now what do? You pick a point to the left of 0. You pick a point between 0 and 2. You pick a point after 2, right? And you see which ones work. Well, once you put them into this, you're going to get negatives for this. You do the work. You're going to get positives for this. You're going to get negatives for this. So what does that mean? That means it's everything between, 0 and 2. So how do we write that nice and neat? We write x. Let me see. I didn't even write the final answer down. That's silly. Okay, but anyway, x is any number between what? 0 and 2. So you can try it. Pick any number between 0 and 2. It'll make this positive. Pick a number to the left of 0. It'll make it negative. Pick any number to the right of 2. It's going to make it negative. So only the numbers between 0 and 2 make this thing work. Okay? So here you go. It's, I think, let me double check, see if my lesson plans, yep. Yeah, I was just double checking to see if it's right. Everybody's leaving without seeing the problem? Okay. It is, but I was just double checking because sometimes I write it down here and on RenWeb it might be different. So it's good to hear me out. And this is section 4, what is it, 7? 4.6. Thank you. Section 4.6. All right, so there you go. You're only doing the odds. Everybody see that? 13 to 21, then you skip up to 29, do to 33. You're only doing the odd problems.